Hi everyone, welcome back. We are now going to talk about the squaring function. So again, if we think about f of x being equal to y, if we want to know what the graph is, it's just really the graph of the equation y equals x squared. So let's plot some of the points that are on that. So we'll move over to a different color pen here. So the origin, again, is going to be one of these points. So 0, 0. Another one of these points are going to be 1, 1. And then another one of these points is going to be 2, 4. Then we get similar points on the other side, negative 1, 1, and negative 2, 4. And so our graph is just going to be these little curved sections like this, going both directions. So this is why it's important to scale, because once you start drawing curved stuff, like there, that wasn't so great, so I'll draw it one more time. It gets pretty difficult to do without practice. And then these, and knowing these points are going to help us when we do transformations, because when we talk about transformations, we'll talk about adding and multiplying certain coordinates by certain values. So make sure you know all these coordinates. Let's talk about some properties. The domain is all real numbers, because this, even though it looks like it's going up here, it doesn't really look like it's stretching out here. As we keep going up, up, and up, it's just going to keep encompassing all the x values in this way, and it's going to encompass all the y values in this direction. So the domain is all real numbers, and then the range is from 0 to infinity, because if we get down here, we will never actually hit anything on the graph. The symmetry is odd. No, it's not odd. Let's cross that off. That is wrong. It is even. As soon as I said it, I knew it was wrong. Forgot to change that. So this is even, and the reason we know it's even is because it has the symmetry around the y-axis, which you can see in the graph, because if we take this part, and spin it around the x-axis, it'll completely cover that part up. But that's not a proof, because graphs can lie to us. So quick proof of evenness. So if we look at f of negative x, this is negative x all squared. So this is negative 1 squared x squared, which is just x squared, which is our original function. So that is even. And behavior. So as we go this way, our y values are eventually going up this way. So we're going to go up and to the right here as x gets larger. So this means we have upright behavior. And here, this part here, notice as x gets really small, the y values get really large again. That's because when we square a number, the negative goes away. So everything, so these really small negative numbers, when you square them, become these really large positive numbers. And so this is going up and left. Increasing and decreasing, well, again, that's just talking about our person walking on the graph. So if we start a person way up here and make them walk this way, notice they're going downhill until we get to here at 0, and then they start walking uphill then. So we're increasing from 0 to infinity, and we're decreasing from negative infinity to 0. And then we are never on a level playing field, or not a level playing field, a level plateau or plane. So there's nowhere that it's constant. So there we go. That is the squaring function. Up next will be the cubing function.